Hi, welcome to my video on place restrictions on a function so that inverse is a function, part 1. I have some diagrams done and some equations. Each fails the horizontal line test. So each of these down here fails the horizontal line test. State the restrictions on each so that the inverse is a function. Notice that this one fails the horizontal line test because it passes through 2 points. This passes through 2 points. Horizontal line passes through 3 points. Horizontal line passes through 3 points. So they fail the horizontal line test. So what are the restrictions? Well, the vertex is 1, x is 1, y is 2. So the restrictions have to be in terms of the axis of symmetry. We're split into 2 equal pieces. 2 symmetrical pieces, I should say. So we will split it at x is less than or equal to 1, or x is greater than or equal to 1. So when we split it, what happens? We get this left side is right here. This is one piece. So when you take the values of x less than or equal to 1, you only get this half part of the parabola. And that means it passes the horizontal line test. So if we split it on this side, x is greater than 1. Oh, I said greater than 1. I put a 0 there. X is greater than 1. This is this side. So less than the x coordinate, the vertex, is the left side, and greater than 1 is the right side. And the same here. The vertex of this parabola is x is 0 and y is negative 2. So the left side is here. So the restriction is x is less than or equal to 1. This is the left side. And the other restriction is x is greater than or equal to 1, which is the right side. And now we have a cubic equation, or if you want to call it cubic. So we want to notice that the horizontal line passes through here, or here, and here, or this point, and this point. So if I name this point as negative 1, 2, and I name this point right here as x is 3 and y is negative 2, then we can divide this cubic graph into 3 pieces. So if we take the values of x that are less than negative 1, x is less than or equal to negative 1, that means I have this part of my graph. And as a result of restricting it, this passes the horizontal line test because it's only this part. And if we also go from negative 1 less than or equal to x less than or equal to 3, which is this part of the graph, it passes the horizontal line test because it only passes through one of these points. Or if we take it, x is greater than or equal to 3, which is this piece here, we also pass the horizontal line test, so its inverse will be a function. So let's look at this one. We have this graph. So this peak point here, x is 3, y is 0. And this point here, x is 0, y is negative 3. So if we draw a horizontal line, it will fail the horizontal line test. So we have to restrict it. So let's restrict it as x is less than or equal to negative 3, which is this piece. So that inverse of this piece will be a function because it'll pass the vertical line test. Or we could restrict it going from x is, did I say x is less than or equal to negative 3 or 3? I meant x is less than or equal to 0. It's the x coordinate that I have to restrict it at, 0. Now right here it's from 0 to 3, so 0 is less than or equal to x less than or equal to 3. So that's this piece of the graph. So the inverse of this piece of the graph will pass will be a function, will pass the vertical line test. Or the other piece, x is greater than or equal to 3. That's this piece. The inverse of this part of the graph will pass the horizontal line test, and its inverse will be a function. Okay, that's looking at the graph. What about if we have an equation? Well, if we have an equation, this is the parabola. All three of these are parabolas. Now, the vertex of this parabola, when you let x equal 0, y is 1. So the restriction occurs at the x-coordinate of the vertex. So the restriction, x is less than or equal to 0, or x is greater than or equal to 0. So this is the left side. So if you look at this parabola very quickly, if you got x is 0, y is 1, this parabola opens up because it's positive. So there's the parabola. So that means that when I say x is less than or equal to 0, I'm picking the left side. X is greater than or equal to 0, I pick the right side. And we have another parabola. The vertex is x is 3, y is negative 1. So the restrictions are occurring at x is 3, so we go less than or equal to 3, or x is greater than or equal to 3. And again, just to draw the parabola very quickly, the vertex is x is 3, y is 1. Parabola is positive, is opening up. There it is. And so x is less than or equal to 3 is this side, the left. X is greater than or equal to 3 is the right side. And we have a vertex of this parabola. X is negative 4, y is 0. So the restriction is x is less than or equal to negative 4. X is greater than or equal to negative 4. And again, draw the parabola. X is negative 4. Y is 0. There it is the vertex. And because that's negative is opening down, so there it is there. Just a sketch. So the left side is right here. X is less than or equal to negative 4. And this is the right side, which is this, which is greater than or equal to negative 4 is the right side. And again, each piece passes a horizontal line test, so therefore the inverse will be a function. And the vertex of this parabola, when x is 0, y is negative 4. And we have 0 is in the middle, so we take less than or equal to 0 and greater than or equal to 0. So we have a parabola whose vertex is x is 0, y is negative 4. Let's say that's right there. And there's the vertex, and because that's negative, it's opening down. And so this is x is less than or equal to 0 is the left side, and x is greater than or equal to 0 is the right side, because the axis of symmetry makes it symmetrical. Okay, hope you understand how to find the restrictions on the parabola to make the inverse a function. Now we have 4 more equations, and they're all parabolas. Parabolas is the easiest one to explain about the restrictions. So we have a parabola, so we have to make this parabola into, the parabola should be into a outside of x minus h all squared plus k. If you can write the equation in this form, then you can find this vertex. Or if you do negative b over 2a and plug it back in, you get the x and the y coordinate of your vertex. So one way I'm going to do it, I'm not going to do negative b over 2a to get the x coordinate and plug it back in. I'm going to do it by completing the square, just to do a little bit more math. So this is x squared minus 4x plus 4. That's a perfect square trinomial. Because if you take the plus at the end, and 4 squared is 4, the square root of 4 is 2. So the square root of this doubled is right here, and there's a plus at the end. So this is an x minus 2 all squared. Remember, that's an x minus 2 times x minus 2 when you factor it. So it's x minus 2 squared. So the vertex of this parabola is 2, 0. So that means the restriction is 2. So it's x is less than or equal to 2. That's the left side. X is greater than or equal to 2 is the right side of this parabola. Now we have a similar equation, but it's not a perfect square trinomial, so we have to make it a perfect square trinomial. So what we'll do is we'll move the 1 over. A half of 6 is 3. 3 squared is 9, so I make it a 9. By taking a half of this term, this coefficient here, and squaring it, I make this a perfect square trinomial. But I put a 9 here that wasn't here before, so to balance it, I got to take a 9 off. So now I have, this is a perfect square trinomial, so it's an x, a half of plus 6 is plus 3 squared. So this is x plus 3 squared gives you that trinomial minus 10. So now the vertex is x is negative 3, y is negative 10. So it's split at the x coordinate of vertex. X is less than or equal to negative 3, or x is greater than or equal to negative 3. So this is the left side of this parabola, and this is the right side, greater than or equal to negative 3. Okay, let's look at another equation. So we have the h of x, we have a 2 in front, so we have to factor out the 2. So when I factor out the 2, I get 2x squared divided by 2 is x squared. 10x divided by 2 is 5x. So we have to make this into this form. So the 2 is outside. So similar to before, we got to complete the square. Half of 5. So we take a, take a 5. Take the 5, divide by 2 and squared. So that's what we call the b divided by 2 squared. That gives you what the c is. The c is equal to b squared divided by 2. So 5 divided by 2 squared is 25 over 4. So to make that a perfect square trinomial, we have this as a 25 over 4. But this wasn't here before, so we got to balance it. So 2 times 25 over 4 gives you 25 over 2. And that's a plus, so we make it a minus, so it balances it out. So now we have the h of x equals 2. The perfect square trinomial is x plus a half of 5 is 5 over 2 squared minus 25 over 2. So the vertex is negative 5 over 2, negative 25 over 2. And as a result, we have, this is the x coordinate, so x is less than or equal to negative 5 over 2 as the left side. X is greater than or equal to negative 5 over 2 as the right side. Okay, we have one more to do to finish off this video. Let's complete the square. Y equals, take the negative 3 out, because you should have a 1 coefficient when we complete the square. 1 should be in front of the x squared. So we take out the negative 3, we get an x squared minus 8x. And we're going to complete the square, so the minus 46 goes over to the right. Let's continue. X squared minus 8x. So a half of negative 8 is negative 4. Negative 4 squared is 16. That completes the square. But we have a 16 here that we didn't have before. So negative 3 times 16 is negative 48. So to balance it, we put a plus 48. And that makes it negative 3 outside of. Half of negative 8 is a negative 4, because this is a perfect square trinomial. And this is a plus 2. So the vertex of this parabola is 4, 2. So the restriction is x is less than or equal to 4, or x is greater than or equal to 4. Just some extra questions and working the parabola that we did in previous units in Algebra 2. So that's how we do the restrictions on a parabola. Take the left side and the right side. When we find a vertex, we do the left side is less than or equal to, and the right side is greater than or equal to. And that brings us to the end of the video. And again, if you like the video, click the like button. Click the subscribe button if you're not a subscriber if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, all one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.